This video is going to outline how to use the Tracker Physics program to get position time data for an object that you've videotaped the motion for that object. I've gone to some search engine. I just happen to use Yahoo here, but you could use Google, whatever you want. If you search Tracker Physics, the very first link here, Tracker Video Analysis and Modeling Tool for Physics, is the one that we want. If you, I just opened it in a new page, and you'll see there's Download Tracker 4.87 installer for all these different operating systems, so obviously you can choose whichever one you need. Run that installer, and you're going to get a program that has this little icon right here, and if I double click on that, the program will open here, and this program is going to interpret a video. So if I go over to the tab entitled Video and I click on it and click Import, I made this video just to show a tennis ball dropping so that we have something to work with here. There I am, there's the tennis ball, and we can see if I just play the video. Here we just have a little bit of delay at the beginning. That's fine when you're making your video. You can do that as well to make sure you get the full motion in your video. It doesn't matter if it starts a little bit late. And there goes the tennis ball to the floor. And so what you can see is, because this program knows how much time elapses in between each one of these frames, if we look at where that tennis ball is, and then we use our calibration for the tennis ball, or our calibration for the video, specifically that that ruler that you see in the background there, then what we can do is chase how that tennis ball's position is changing over time. First thing first, I can put my axes here, and this is a little bit confusing because the video is rotated, and so it looks like down is positive X, but that's fine, we can just interpret that later. In the meantime, I do need, the video doesn't know how big things are, so we need some sort of calibration here to show exactly how long or how far that distance is. That's why we put that meter stick in the background. You should put a meter stick in the background of your video as well. You should also make sure that whatever motion of the object, the meter stick is pretty close to the same distance away. Just like when you look at things that are far away, they look smaller. You don't want to have that same sort of distortion in your video when you're trying to chase the motion of the object. So that the blue line here, the calibration stick, again I went to my little tool here, I clicked on it, I chose the calibration stick, and you'll notice that I've renumbered the length of that calibration stick from 100 to 1. If it was 100, I guess for a meter stick it would assume that that's 100 centimeters, but really I just want to be working in meters, so I've changed it to 1 meter. And then all my data will be in meters, and that will make it a little easier. So I'm going to track a point mass, specifically the tennis ball. So if I go track new point mass, then the program is ready to chase the location of that tennis ball. You'll recall from watching the video the first time that there's a whole bunch of time at the beginning here where nothing's happening, so I'm just going to scroll ahead till I'm at least ready for the tennis ball to fall, somewhere right about there. I'll use that frame as my first frame. And then I'm going to start recording the position and time of this tennis ball during its actual motion. If I hit Shift, that tells the computer that when I click, what I want to do is record the location of the tennis ball. And I want to make sure that tennis ball isn't infinitely small. It's got a little bit of size to it, so I want to try my best to click on the same part of the tennis ball each time I click. Now you're going to notice as you're doing this a couple things. First of all, the frame of the video advances each time you click. And you're noticing that we don't have a high quality camera here. We're just using a phone camera to take this video. And so the tennis ball is getting a little bit blurry. So it's getting harder and harder to be really consistent with where on that tennis ball we're considering the leading edge. But you just do your best there. That's a nice source of error if you have to discuss error in this lab at some point. Secondly, you'll notice that it's actually plotting the points up on the right hand side, and we can see a nice quadratic forming here. And that's good because this is a uniform acceleration, hopefully at negative 9.8 meters per second squared from something falling, so we can see that we're getting the expected shape. Now I've got, I don't know, 15, 20 data points there. That should be plenty. I'm going to highlight the two columns of interest. Here I have my motion in the X direction in my time. I'm going to hit Control Copy. I'm going to open up the Excel program, and this will paste nicely into Excel. See, it's got for mass A, there's your time, there's your X, and don't get fooled by Excel's notation for scientific notation. This 2.5 e to the -1 is really Excel's way of saying 2.4 times 10 to the -1, or 0.249. It won't affect it when you go to use it as a graph or anything like that, even if it's E00, so you don't have to worry about that at all. So hopefully, based on that video, you'll be able to find the tracker program, take a video on whatever device you want to use, import the video to Tracker. The Tracker program wants to use QuickTime to watch the video, so you're going to need QuickTime as well, which is free. And make sure you calibrate, set your axes the way you want them, get the data points, and move them over to Excel. What to do with them in Excel, I'll do in another video.